Good day, I am Alexandra Ashley M. Olsem, taking ECE A111, Section EO2 under Engineer Marian N. Sahara, and this is my coursework today. Starting with the spread spectrum techniques, we have direct sequence or DSSS. The PRN is applied directly to data entering the carrier modulator with the DSSS approach. As a result, the modulator sees a considerably higher bit rate, which matches to the PRN sequence's chip rate. When such a code sequence is used to modulate an RF carrier, it results in a direct sequence modulated spread spectrum with a sin x over x squared frequency spectrum centered on the carrier frequency. So the main lobe of this spectrum has a bandwidth twice the modulating code's clock rate, while the side lobes have null-to-null bandwidths equal to the code's clock rate. The most frequent sort of direct sequence modulated spread spectrum signal is seen in the figure. The spectral form of direct sequence spectra varies depending on the carrier and data modulation applied. So we can see this illustration here on the right for DSS. Next, we have frequency hopping or FHSS. The FHSS approach causes the carrier to hop from frequency to frequency across a large range in a sequence set by the PRN. The data rate of the original information determines how quickly the hops are executed. However, this is a distinction to be made between fast frequency hopping and low frequency hopping. So the latter approach, which is the most prevalent, permits any data bits to modulate the same frequency at the same time. So this signals transmitted spectrum differs significantly from that of a direct sequence system. The frequency hopper's output is flat over the band of frequencies employed rather than having a two-shaped envelope seen in the figure on the right. So the bandwidth is simply n times the number of available frequency slots, where n is the bandwidth of each hop channel. Next, we have time hopping or PHSS. It is a signaling technique that can be used to produce anti-jamming or AJ or a low risk of being intercepted. It can also refer to pulse position modulation, which uses 2K discrete pulses to broadcast K bits per pulse in its simplest form. Last, we have the chirp spread spectrum or CSS. Is a spread spectrum technology that uses wideband linear frequency modulated chirp pulses to encode information in digital communication. Chirp is a sinusoidal signal that increases or drops in frequency over time. So moving on, we have also multiple access techniques. First, we have frequency division multiple access or FDMA. This is a communication channel which is assigned as a specific carrier frequency using FDMA. The number of different uses is restricted by the number of frequency spectrum slices. Here, slices. In terms of frequency band consumption, FDMA is the least efficient of the three ways for providing multiple access. Radio broadcasting, television, amps, and tetrapole are all FDMA access methods. Next, we have the time division multiple access, where different users speak and listen to each other according to a set of time slots when using PDMA. For a given carrier frequency, different communication channels can be formed. GSM, DECT, Tetra, and IS-136 are all examples of PDMA. And lastly, we have code division multiple access or CDMA. A key or code determines CDMA access to the airwaves. Spread spectrum is a CDMA access in that sense. At both the transmitter and receiver ends, the key must be defined and known ahead of time. IS-95, IS-98, Bluetooth and WLAN, or WLAN, are all becoming more popular. So here is the illustration below, and here is the reference for my discussion on on spread spectrum communications. And thank you.